Hi guys, I'm Dr.S.Nandhabalaji. Today we are discuss about the properties of matter in the topic of elasticity. Today we are discuss about the introduction of the elasticity. First of all, what is elasticity? Elasticity is a material ability to deform under stress and return to its original shape once the stress is removed. This is fundamental concept in the mechanical engineering and material science and the relations of stress and strain. The stress and strain relations describes how a material behaves under applied force. It's a crucial aspect of understanding a material's mechanical properties. Like as stress is defined as a force applied per unit area of a material, and then strain is measures the deformation of a material in response to stress, represented as the change in length divided by the original length. Like a stress and strain, different types of stress and strain graphical representations, like as elastic region, yield point, plastic region, and ultimate tensile strength and fracture point. In this elastic region, the initial portion of the diagram where the material deforms elastically, meaning it returns to its original shape after the load is removed, and yield point, the point on the diagram where the material starts to deform permanently, indicating the end of elastic behavior. Plastic region, the portion of the diagram beyond the yield point where the material deforms permanently and does not return to its original shape. And tensile strength, it's a maximum stress and material can withstand before it begins to fracture. And fracture point, the point on the diagram where the material breaks or fractures. These are the different types of stress and strain diagram relationship. And the relations of stress and strain diagram, Hooke's gives the law that Hooke's law states that the force needed to extend or compress a spring is proportional to the distance the spring is extended or compressed from its equilibrium position. So Hooke's derived the stress and strain. It's directly proportional to medium. So stress is directly proportional to strain. So we have a constant of elastic constant E. So stress is equal to E into strain. So elasticity is called as stress by strain. In this Hooke's law defined as a two different types of constants. One is linear elasticity. Within the elastic limit, the stress is directly proportional to the strain. And spring constant, the constant of proportionality in Hooke's law representing the stiffness of the spring. Applications of this elasticity is Hooke's law is widely used in various applications including springs, shock absorbers, and other elastic elements. And the point of explanations, the elastic limit, the maximum stress a material can withstand before permanent deformation occurs. In yield point, the point where the material start to deform elastically, even fixed the point. And the plastic deformation and fracture of the elastic material. Plastic deformation refers to the permanent change in shape of a material after the stress exceeds the yield point. Fracture occurs when the material breaks under stress. First of all, plastic deformation. The material undergoes permanent deformation that does not reverse when the stress is removed. Necking. The material begins to thin in a localized area due to plastic deformation, leading to a reduction in cross-sectional area. Fracture. The material breaks or separates under different kind of materials. Applications of stress strain diagram like as material selections, design optimization and quality level of control. These are the different kind of applications like as material sections. Engineers use the stress strain diagram to choose material with suitable strength and toughness for specific applications. Design optimization, understanding the stress strain behavior helps optimize designs to minimize stress concentration and prevent failure. Quality controls like stress strain testing is used to ensure the quality and the materials quality controls and verifying the required specific materials qualities. Importance of understanding elasticity. Understanding elasticity is crucial for designing a building structures that can withstand loads and remain stable, like as bridges, buildings, vehicles, and aircraft. In the bridges, the elasticity of steel and concrete is essential for designing bridges that can safely support traffic loads. Buildings. The elasticity of building materials allows them to deform under wind loads, preventing failures. Vehicles. The elasticity of metals and plastic is essential for designing car parts such as springs and bumpers to absorb impact. Aircraft materials. The elasticity of aerospace materials play a crucial role in the design of aircraft components, ensuring safety and structural integrity during flights. Thank you, guys. Thank you very much.